All right. So we do need to remember a couple of things. One, the derivative of our tangent, okay, is 1 over 1 plus x squared. Okay, derivative of our sine is 1 over the square root of 1 minus x squared. And dx of our secant x is 1 over f of x squared x squared plus 1. That's it.
Wait, it's 1 over.
1 of the absolute value of x squared of x squared plus 1.
And those are the only two we need to know.
Yeah, well, the reason why you don't need to know the other ones is because if you have a negative 1 up top, it's like negative 1 is our cosine, negative 1 is our cotangent, negative 1 is our cosecant.
Yeah.
That thing. So if it's negative, then it's the cos.
It has to see at the start of this thing.
Yeah. So we are going to do this backwards. Now, this, what do I have to have up top? A 1. What do I have to have in the denominator? What number do I have to have in the denominator? 1. So if I don't have a 1, what we can do is factor it out. Okay, so number 1, we can factor out a 4 or a 1/4 out of the interval. So we write this as 1/4 integral of 1 over 1 plus jump set. X squared over 4 dx. Now, we don't like that. We want to have something square. Okay, what I mean by that is we want to write this as 1/4 the integral of 1 over 1 plus x over 2 squared. Yes. All right. Now, we could do use substitution, but you don't have to. Okay, it's just whatever's inside the parentheses is whatever is inside the arctangent. So we are going to get 1/4 arctangent of x over 2. That's not right. It's not bad. That's what it said in the directions. Long division and completing the square. It's the completing the square where it gets fun.
Oh, yeah.
All right. Now, what do I want to factor out number 2?
None.
None. But what I'm actually going to factor out is 1 over the square root of 1, right? Because it's in the square root. Sure. Which gives me 1 over the square root of 1 minus x squared over 9 dx. What's the square root of 9? 3. Integral of 1 over square root of 1 minus x over 3 squared. Yes. Now, in this case, we don't have to do substitution because, again, what's the derivative of x over 3? What, we don't need to substitute. Hey, I needed to. We'll check this. Yeah, we did need to use substitution. Because I'm not looking for the antiderivative, for the chain rule. Yeah. We'll go back to number 1 just a second. Let's finish this here. So we do need to do the u substitution. U is equal to x over 3, which means du is equal to what? 1/3 dx. Now, notice we actually have a 1/3 dx. That's nice. So we can write this as the integral of 1 over 1 minus u squared du. Right. Which is equal to what? Arc sine. Again, if you want to do this, u plus c gives you sine of x over 3 plus c. Go right ahead. But yeah, number one here, I did have to use those solutions, so that is my
So it's just our sign.
yeah.
Plus three.
So number one, u is equal to x over 2, which means du is equal to 1/2 dx. I don't have a 1/2 dx. I have 1/4 dx. And if you want to bring out a 1/2 there, you could, but it's just easier saying 2 du is equal to dx. And then put the 2 times 1/4. 1 plus u squared du. So we end up with 1/2 arctangent. We're going to want to do u plus c, which gives you 1/2 tangent of x over 2. Let's see. So yeah, we do have to use substitution. Or with what? Always. No. Yeah. Let's see. Just. What is it? Let's just think. Yeah, they over there. Yeah. Oh, this one looks fun because we have our paint here. So, what do you think we're going to do? No, we can't. This is not happening. We can't use calculators without. You're going to substitute. Right? Now, do we already have a derivative here inside the function? Yeah. So what are we going to substitute in for? Arctangent. Right? Because what is the derivative of arctangent? And do we already have that? Yeah, we do. We end up with the integral of u squared du. Lot easier. So that is 1/3 u cubed plus c. So 1/3 tangent of x plus d. Oh, cubed, right? Or put that in parentheses you can.
Okay.
Alright. Here, we need to have a 1 here. Right? So what do we need to factor out? Factor out 1/3. There's factor 3 on the denominator. 1 over 1 plus 16 x squared over 3 dx. Now, I need to write this as something squared. So how would I write this as something squared? What's squared is 16? 4. What's squared is 3? Root 3. Root 3. Now, we have a square in the denominator. That doesn't matter. We don't care about rational denominator. Okay, not anymore. We don't have to ever rectify the denominator again. Okay, no one cares about that. I know it's such a big focus, but it doesn't matter. We don't care in this class. All right, so we are going to do substitution though, because we have to say u is equal to 4x over square root of 3, which means du is equal to 4 square root of 3 dx, which means that 3 square root of 3 over 4 du is equal to dx. Plug that in, we have the square root of 3 over 4 times 1/3, integral of 1 over 1 plus u squared du. That gives you square root of 3 over 12 arctangent of u plus c. Square root of 3 over 12 arctangent of 4x over root 3 plus c. Very good. Not bad, not too bad. Okay. Now, if let's say evaluate using long division, can you do synthetic division instead? Yes. You do not have to do long division. Okay. I prefer synthetic division, so let's just do that instead. And again, the reason why we're doing this is because I can't integrate that. And I can't do any type of substitution because if I substitute, let's say if I substitute for the numerator, it's not going to cancel that denominator out. Okay. Or substitute for the denominator, it won't cancel the numerator out. So what we're going to do is just rewrite it in a different way. Yeah.
And for example, that just show that it doesn't matter.
Yeah, you have to leave the remainder. But yeah, just do your regular division. Or your long divisions, whatever you like. Synthetic division is what I prefer. So 3, 1, 2, 1, bring down the 1, that gives you 3, 5, 15, 16. So now I'm just going to integrate
Wait, hold on.
your synthetic divisions.
You might get
Again, anything below the bar gets multiplied by the box. You put it under the next number, you add 5 multiplied by the box.
How do you get all the numbers?
This right here is x minus 3 equal to 0. This is x squared, x, and my constant.
Okay, and then what about
Always drop the first number. 1 times 3 is 3. Add, you get 5. 3 times 5 is 15. Add, and 16. Now, that last number is always your remainder. So I'm going to end up with x plus 5 plus 16 over x minus 3. So that's where we're going to integrate. So, now the reason why we do that is what's the integral of x? Squared. What's the integral of 5? X. What is the integral of 16 over x minus 3? Yeah, remember if x in the denominator, it's natural log. And you don't have to worry about chain. Why don't we have to worry about chain in this one? Because the derivative of x minus 3 is just 1. So we don't have to worry about the chain here. No substitution needed. Let's see. That's it. Now, if you only have like the same, you only have like a linear function over linear function, what you can do. That's stable, okay. So, what you can do in this instance is rewrite this as the integral of x plus 5. Now, what plus 5 gives you negative 2? Negative 7 over x plus 5. And then we can separate this fraction out as the integral of x plus 5 over x plus 5 minus the integral of 7 over x plus 5. So the interval 1 dx minus the interval of 7 over x minus 5 dx. Interval 1 is just x minus 7 times the natural log of x minus 5. Let's see.
You were gonna do that the long division y, how do you do it?
Long division way?
Or not the long division?
Synthetic division? I mean, you can do the same thing. You want to do synthetic division. Take x plus 5, set that equal to 0. You get negative 5. And now, since all we have is x, we just start with x and then constant. So that's 1 and a negative 2. Drop to 1. So negative 5 times 1 is
Maybe 5.
negative 5. I'm just adding, just doing ahead. That gives you negative 7. So end up with just 1 minus 7 over x plus 5. Which is what we got.
Is that meant to be x plus 5 in the answer on the right?
Yes, it is. That's, I wrote minus 5 and I just kept that right here. Hey, you don't have a lot of these to do. How do you do? Let me see. Worksheet somewhere here. Yeah, you don't have really any of these. Yeah, there's one. There's one question. No, 2 questions. Okay. Never mind, it's 3. Yeah, they're a little bit bigger than these, so they're going to be a little more involved. Now, quick question, because I know it's been a while. What happens if I had, let's say, x squared plus 5x minus 12 over 2x plus 3? You can do long division if you want. Feel free to do that. But if you take 2x plus 3 equal to 0, you get negative 3 halves. So we have 1, 5, and negative 12. Bring down the 1. That's probably not the best way to start. Let's say this was a 4 there. 4, and 1 must be. Okay. Yeah, so it works out a little better. Yeah, that should work out. So, if we did this, we would end up with 4 negative 3 halves times 4 is negative 6. That gives you another 4. Negative 3 halves of that is also negative 6, which gives you negative 18. Now, here's where you have to remember the extra step. Anytime you have a fraction with synthetic division, what do you do with your answer? Remember? You have to divide your answer, not your remainder. Every number except your remainder by your denominator. So divide by 2, divide by 2, we get 2x plus 2 minus 18 over 2x plus 3. So if you do have a fraction, anytime you finish, you need to divide everything but your remainder by your denominator. Now, do you want to know why? Okay. How do we get to the negative 3 halves in the denominator? What I did was I rewrote this as x plus 3 halves by factoring out of 2. Can I just divide the denominator by 2 and not the numerator at the same time? No. So what we're going to do is once we're done, then you divide the numerator by 2 instead of beforehand. Yeah, that's fine. You can't just divide your denominator by 2 without doing the same thing to your numerator or something. So to balance it out, once you're done, divide by 2. That is why. Yeah, that's what I'm telling you. Or you can do long division. If you want to do long division, go right ahead. Full stop. I hate long division. Right. So much better with synthetic. I can get away with it. I would. If I could, I'd find the root. Like, if, you know, how you can only do long synthetic division if your denominator is a linear function. Well, I would find the roots if I could first, and then I need to do two synthetic divisions before I would do long division. Okay. Even if they're complex roots, I wouldn't care. Still easier to do long division or synthetic division than long. Hate long division. So now here's the fun part. Leave the square. So if we have a polynomial in the denominator, like we have 1 over something, again, it doesn't need to be a 1 here, 1 here. So again, we're still going to be using my arc tangent, arc secant, arc sine. Okay. Probably not so much your arc secant. I don't see a lot of that on here. Okay. But arc tangent, arc sine, yeah, definitely does. All right. So what we want to do is we are going to complete the square. Okay. Now, for our tangent, does it really matter if we have 1 over x squared plus 1 or 1 over 1 plus x squared? Does it really matter? No, it doesn't. Okay, as long as you know that whatever this is, what's inside your tangent, you're done. So here, if I want to complete the square, what would I do?
It's like half of b squared.
Now, what I'm going to do is I'm going to take b, so 12 divided by 2 and square it. That's going to give me 6 squared, which is 36. Now, if I add 36 here, what do I have to do to balance that out? Subtract 36 on the outside. So if I add 36 and subtract 36, I didn't really do it. So this gives me an integral of 1 over x squared plus 12x plus 36 plus 1. That's nice that we have a 1 outside. That's what we want. If we don't have a 1 outside, we'd have to factor it out. And that's real fun. So what is this? What factor? In fact, go get the units. Oh. So what is this in factor form? Because I need an x squared. I need some x minus x plus 6. Yes. So we have the integral of 1 over x plus 6 squared plus 1. All right. And again, you could use substitution, but you don't have to, because what's my derivative of x plus 6? Just one. When do we know we need to use substitution? When there's a chain. If the derivative of what's inside my function here is anything other than 1, then I need to use substitution. Now I just say, now I'm going to say that this is our tangent of x plus 6 plus 1, or plus c. That's because we don't have to use substitution here, because my derivative of 1 plus 6 is just 1. So there is no chain. But if there is a chain, you do have to use substitution. All right. Now looking at this, when I do the completed square, what is my end result going to be? Like, what's my function? It's not standard, that's our sign. Okay. So I need to make this look like 1 over the square root of 1 minus x squared. So I need to have it look like this. So which means that if my x squared is negative, then I'm kind of stuck. Is my x squared negative? Yeah, then I can factor out a negative 1, whatever I do to complete the square. So we're going to write this as the integral. That's a little more room here. of 1 over the square root of 3 plus, well, I'll leave it as this for a moment, and I'll factor it out. So 2x minus x squared dx, which we want to write as 1 over the interval of 3 minus x squared minus 2x dx. So when I factor out a minus, I reverse the order. So now my x squared is positive and my 2x negative. I need to have that minus there, because otherwise it's not arcsine. Because I need to have this minus right here to have arcsine. What's going to complete the square?
One.
All right. So if I x squared minus 2x plus 1. Now, if I add 1 inside, and you have to be careful here, what do I have to do outside? Reason being is because if I'm adding 1 inside, what's in front of that parentheses? Negative, which means what I'm really doing is subtracting 1. So to balance that out, I have to add 1 outside. With the interval, that's okay. 1 over the square root of 4 minus, that's going to be x minus 1 squared dx. Questions up to this point? With the 4, 3 plus 1.
Oh.
Now, I don't want 4, do I? Now, so what do I need to do? Factor it out.
1 fully.
So I'm going to factor that one. Well, factor 1 over square root. So 1 over the square root of 4, integral of 1. This becomes 1 minus x minus 1 squared over 4. Not having to prove this. I'm moving. So how do I need to rewrite this to have just one thing being squared? X plus 1 over what?
And that's what.
Oh, x minus 1 minus 1 over 2. Now, do we have to use substitution? Well, we have a chain. Derivative of x minus 1 over 2 is 1 over 2. Now, it works out nicely here because do I have a 1 over 2 already? Yeah, so it'll cancel out that 1 half. So, since u is equal to x minus 1 over 2, then du is equal to 1 over 2 dx, which I have a 1 over 2 dx. So we get the integral of 1 over 1 minus u squared du, which we know to be sine u plus c. Means my final answer is arc sine of x minus 1 over 2.
Integral 1/2 outside of it.
1/2 dx here. We had a 1/2 dx to replace the d. So it was nice that it took care of the 1/2. Doesn't always do that. But that's it for the notes.
Right. Yes.
Yeah. So, that's homework. Feel free to work in groups on this.
This one.
It's all people just like that. I don't know. What?